In this video, we want to go over how to find the intersection of two lines when they are given in slope-intercept form. So let me first write the equations of two lines. So y is equal to 1/2 x minus 4 will be our first one. And doing a quick plot of that, the y-intercept is minus 4. And we can go over 2 up 1, over 2 up 1, over 2 up 1. And plot a couple of more points. And then sketch in the line that runs through all of those points. The second line we want to consider is y equals negative 3x plus 5. So if I put the y-intercept up here and give a slope that's dropping rate of 3 to 1, we can sketch in a line for this. And while my intersection is probably not exactly where it should be, it's clear that it doesn't follow on any grid lines. So we need to find out a method besides just inspecting the graph that will allow us to know where those two lines intersect. So let us consider what to do with this algebraically. What we need to do is find x and y values that correspond to this point of intersection. So both equations must have the same y value at a specific x value. When x is equal to whatever the value of that point of intersection is, the y value for both lines must be the same. Since that's true, we can write that 1/2 x minus 4 must equal negative 3x plus 5 at that particular x value. So now to figure out what that x value is, we have a simple, we have one equation that has x as its only variable, so we can proceed with standard algebraic techniques. I think the easiest thing to do in this case is to start by multiplying both sides of the equation by 2, and if we double both sides, the left becomes x minus 8, and the right-hand side becomes negative 6 plus 10. Note that we doubled every term. Now in order to solve this, if we add 6x to both sides and add 8 to both sides, we will end up on the left-hand side with 7x, and on the right-hand side we will end up with 18. So the x value where the lines intersect must be at 18/7, which is 2 and 4/7 as a mixed number. So when we look at our x coordinate here, it looks like this is probably the right answer because it's clearly at a between the integers 2 and 3, probably somewhere in the middle, and 2 and 4/7 is nicely tucked into the middle. But we still don't know what the y value is. In order to get the y value, we need to substitute our x value back into one of the two equations. Given that the purple equation is probably the simpler of the two, I'm going to substitute my x value back into that equation. So I can say that y is negative 3, and then I can take the x value that we just determined was true and proceed from there. Notice I picked the improper fraction to work with rather than the mixed number. So multiplying by 3, we get negative 54/7. And then since we're going to want a common denominator for our addition, we're going to call 5, rename it 35/7. And now we have to finish up by adding the two fractions. And when you add those up, you end up with, it looks like negative 19/7. Okay. Now if we wanted to, we could rewrite that as a mixed number of negative 2 and 5/7. So notice it's very close to what we had for the x value, except that it's negative. So in size it's almost the same, but it's negative 2 and 5/7. That looks like it could be true because the y value that we need to get is clearly between 2 and 3, and so negative 2 and 5/7 could work. So Where's the point of intersection? It is at, using improper fractions, 18/7 comma -19/7 is the point of intersection. So quick review. When you have your lines given in slope-intercept form, you can equate the expressions for x in both of the equations because we're looking for a place where the y values would be the same. So we're looking for the x value that would make the y values equal to one another.